Okay, guys, so today we're going to be looking at cause and effect. To start off here, it says a strong correlation does not prove that the changes in one variable are the direct cause of changes in the other. Okay, there are types and degrees of relationships or causal relationships between variables. Okay, so there's different ways. Just because two things are changing or two variables are changing at the same time, it's not always just because one is impacting the other. It could be because the change in X impacts the change in Y, but sometimes there are other reasons as to why um, a change in one variable might cause a change in another. Okay, so first one, cause and effect, like I just mentioned. A change in Y produces a change in X produces a change in Y. Example, increasing the height of a dropped object increases its velocity. Okay, so that one would be, a direct cause and effect. The cause is the height, and the effect is the change in velocity, right? So that one's pretty straightforward, I would hope. Number two, common cause factor. So an external variable causes two variables to change in the same way. Okay, so example, the increase in beach parking, so there's more cars at the beach, correlates with the increase in the tomato harvest. Okay, so you could look at the data, and you could see, oh, at the same time, there's way more cars parking at the beach, as there are, and that is happening at the same time as an increase in the tomato harvest. Okay, but we know those two variables don't really have anything to do with each other. Okay, so the common cause in this case would be the warmer weather. Okay, so the warmer weather is the common cause or the external variable that is causing both the beach parking to increase and the tomato harvest to increase. Okay, so there's one where it's an external variable causing the two things in question to increase at the same time. Another one we have, number three, is reverse cause and effect. So the dependent and independent variables are reversed in the process of establishing causality. Okay, so researcher says or thinks that drinking coffee causes nervousness, but in the course of his research actually realizes that it's the opposite or the reverse, that nervous people drink coffee. Okay, so this is what we would call reverse cause and effect, where the theory or the thought at the start was drinking coffee is independent, nervousness is dependent. And doing your study or your research, you actually find that those two variables flip, and the nervous people become the independent variable, and the drinking coffee becomes dependent. Okay, so when they flip like that, we call that reverse cause and effect. Number four, you could have a totally accidental relationship. So a correlation exists without any causal relationship between the variables. So example, as school enrollment increases, the number of reality shows increases. So that's totally accidental, or you can say totally coincidental. There's no actual causal relationship between school enrollment increasing and the number of reality shows increasing. Okay. Last one is presumed relationships. So a correlation does not seem to be accidental, yet there is no cause and effect or common cause relationship apparent. Okay, so in this case, we have an example: correlation between people's fitness level and the number of action-adventure movies watched. Seems logical. So what they're getting at here is, we can assume, or they are assuming, that fit people or people that are more fit are, more likely to watch action-adventure movies. Okay, so we're assuming that's the case. So it seems logical, but you can't prove it. There's no way to prove that a fit person watches action-adventure movies, or someone that watches action-adventure movies is more fit for that reason. Okay, so in this case, we can say presumed relationship, or you're assuming a relationship, but we can't prove it. Okay, so that would be the fifth way. The other thing we want to look at in this lesson is extraneous variables. Extraneous variables, also known as external factors, affect either the dependent or independent variable. Okay, so it can affect either one of those, right? It doesn't have to affect just the independent or just the dependent. So for example, if we looked at a low exam mark, some extraneous variables could have played a role in achieving that mark. So here you see a list of examples of extraneous variables that could have impacted that low mark. So the person could have had a busy exam schedule. They could have been working, a part-time job at the same time as exams were going on. The actual amount of time spent studying. Maybe the time of day the exam was written had something to do with it, right? Maybe it was super early in the morning, or maybe it was really late at night and the person was really tired and couldn't think straight. Maybe the place the exam was written at could have had a impact, right? Maybe it was noisy, maybe it was dark, whatever the case may be. So these are all examples of potential extraneous variables that could have impacted or had a role in achieving the low exam mark. Okay, so when researchers do experiments to reduce the effect of extraneous variables, they use experimental and control groups. The experimental group and the control group should be as similar as possible. Researchers vary the individual variables for the experimental group, but not for the control group. Okay, and then any differences in the dependent variable for the two groups can be attributed to the changes in the independent variable. Okay, so in this case, what we're talking about here is you'd have an experimental group and a control group, so you want them to be as similar as possible. So let's say we're looking at our exam marks for our data class. So maybe we look at all the data students at OT, and we take half of them and put them in the experimental group, and take the other half and put them in the control group. Okay, so now they're similar as possible. They're all data students. They're all OT data students. Researchers. So the second part is researchers vary the individual variables for the experimental group, but not for the control group. So what we would say in this case is, for the control group, you don't change a thing. So the kids or the students in the control group go about their daily lives. They study how they normally would study. If they're working, they keep working. Wherever they're told to write the exam based on the exam schedule, they write it. So they don't change a thing. The experimental group is where the individual variables are actually varied. So the researchers may say in the experimental group, everyone has to write their exam at 8 in the morning. Okay. So maybe you're theorizing that the time of day has an impact on the exam mark, and you want to see if that's actually true. So the control group writes the exam whenever they're normally scheduled to write it, whether it's 8 a.m., 11 a.m., 2 p.m., 6 p.m., whatever the time might be. And the experimental group is the one that the researchers actually change and say, okay, no, you guys are all writing at a certain time. So let's say 8 a.m. Once all that happens, you get the exam results. Then any differences in the dependent variable for the two groups can be attributed to changes in the independent variable. So if there's differences in the marks for the two groups, right? So let's say the people that wrote the exam at 8 a.m., their marks are all a lot lower on average than the people that wrote their exam whatever time they're scheduled for. Now you can say that, okay, you have some proof or you have some data to show that the time of day, writing at 8 a.m. in the morning, did have a detrimental effect on the exam marks. Okay, so that's how you would deal with experimental and control groups. Last thing let me just check here. Yeah, before we look at our examples is the Hawthorne effect. Sometimes a behavioral change will occur due to the psychological effect of participating in a study. A behavioral change that results from subjects who know they are participating in a study is called the Hawthorne effect. Okay, and how do you deal with this behavioral change resulting from the psychological effect of participating in a study? Something that you might have heard before is called a placebo. A placebo is an inert drug that produces behavioral change based on the psychological effect rather than a medical or chemical effect. Placebos can be used to neutralize the Hawthorne effect among other forms of experimental control. So the most common example you probably hear about in the news is, if a pharmaceutical company is testing a new drug, let's say a pain reliever, and they have their groups they're testing it on, what will happen is some people will start feeling relief from their pain because it's a psychological result of them taking a drug. So maybe the drug itself had nothing to do with the pain being reduced, and the pharmaceutical company wants to figure out, is the medical ingredients or the chemicals in the drug helping, or is it just something that's happening psychologically because the person in their head is thinking, oh, I took this pill, so now automatically I feel better. So what they would do then is they'd have their control and experimental groups So one group would be the control group would be given the placebo, which basically could be like a sugar pill or some sort of pill that has no sort of medical ingredients in it. And then the other group would be given the actual pill that has the medical ingredients in it. And then they could compare the two to see that are their medical ingredients actually having an impact on pain relief, or is it more, or are people feeling better based on this placebo effect, where just because they took a pill, even though it was a sugar pill, they're reporting that that they feel better. Okay, so that's one way to reduce the Hawthorne effect is give half of your subjects the actual drug, and then the other half you give them something that has no medical ingredients in it whatsoever, and compare the results between the two groups. Okay, few examples here. Determine the type of relationship. The rate of chemical reaction increases with temperature. So that is your, I guess, simple cause and effect. Higher temperatures cause faster reaction rates. Okay, so change in temperature causes change in reaction rates. B, leadership ability has a positive correlation with academic achievement. So this we would call a presumed relationship. A positive correlation between leadership ability and academic ability seems logical, yet there is no apparent common cause factor or cause and effect relationship. So there's no actual proof, even though, like we have said here in the solution or the answer, that it does seem logical. So that because it seems logical, but there's actually no common cause or cause and effect, we call that our presumed relationship. For C, the prices of butter and motorcycles have a strong positive correlation over many years. So really, we can tell that the price of butter and the price of motorcycles really would not have anything to do with one another or actually impact one another. So this one would be a common cause factor. So just like the one with the beach parking and the tomato harvest, here inflation has caused parallel increases in the prices of butter and motorcycles over the years. Right, so as we have inflation every year, a couple of percent, usually, give or take, the prices of all goods, really, but in this case, the price of butter and motorcycles would go up simultaneously. Okay, so common cause. Sales of cell phones had a strong negative correlation with ozone levels in the atmosphere over the decade. This one, we'd say accidental relationship. The correlation between sales of cell phones and ozone levels is largely coincidental. However, it is possible that the chemicals used to manufacture cell phones cause a small portion of the depletion of the ozone layer. So with some of these, you can make the argument that it could fall under more than one type of relationship. So as long as you're making a logical comparison and proving or showing why you feel it's a certain type of relationship and your explanation is accurate, you can argue for more than one type of relationship. And that's what we're saying here. We're saying accidental, but you could argue that, cell phones emit chemicals that could cause a detriment to the ozone layer. Traffic congestion has a strong correlation with the number of urban expressways, and here's a perfect example of two different relationships that you could easily argue. It could be cause and effect, and it could be reverse cause and effect. So originally, expressways were built to relieve traffic congestion. So traffic congestion led to the construction of highways or expressways. However, numerous studies over the last 20 years have shown that urban expressways cause traffic congestion by encouraging people to use cars more. Okay, so both work here. You can say it's the traffic congestion resulted in highways being built, right, which would be cause and effect. And you could say reverse cause and effect and say, you know what, that's what we thought, but actually the fact that urban expressways were built or highways were built, that actually caused the traffic congestion. So either one works there. And you can see in red, that's all it says. These examples demonstrate several types of relationships can be involved in the same situation. Okay, so again, as long as your logic, your explanation makes sense and is accurate, that's fine. Okay, so we'll leave it at that there.